So after the pH question, let's do this question first. Let's read this. What did they give us? At 0 degrees and 1 atmosphere pressure, a gas occupies 100 cc volume. Okay, right. So they've given temperature is given, pressure is given, and volume also is given. Done. If the pressure is increased to 1.5 times and the temperature is increased by 1/3 of the absolute temperature, the final volume of the gas. I think I have done this numerical, but I'll do it again. Let's see. What should I find out? If the pressure is increased by 1.5 times, the temperature is increased by 1/3 of the absolute temperature. I have to find the final volume. So first of all, let us note they have given us P1. What is P1? 1 atmosphere. What is P2 given to us here? They said it is increased to 1.5 times, that is 1.5 atmospheres. Then next T1. T1 is 0 degrees. Here what is T2? They've given it is increased by 1/3 of the original absolute temperature. That means 1/3 of original. This one is 273 plus 273 into 273 plus 273. Done. This comes to 364 Kelvin. Now volume is what is the initial volume? It is 100 cc. See here, 100 cc. I have to find the final volume. Now according to the formula, P1 V1 by T1 is equal to P2 V2 by T2. Substitute the values. 1 into 100 by 273 into, because I have to find out V2, I'll take this V2 outside, 364 by 1.5. When I solve this, I get an answer of 88.9 cc. This is done. Yes, so the correct answer is 88.9. Right, now let's come back and see one more question. This is again a grade 11th question. Hope I'm not going fast, students. So clearly I'm explaining this, and if you have any doubt, please do send your questions in the comment section. Right, next question. Which of the following is never true for cathode rays? Right, so I did this question also earlier. We very well know cathode rays are basically or they contain, or they have flow of electrons, means there is a beam of electron which flows in the cathode discharge tube. Correct? Because of those electrons, they have kinetic energy. They produce, means there's always a pressure which is created inside. Heat also is produced. But what is never true? This is the correct option. They are electromagnetic waves. Basically, we very well know, I told you, cathode rays have beam of electrons. But they are not electromagnetic waves. Why? Because electromagnetic waves contain photons. They are not electromagnetic waves as these contain photons. So this is a statement which is never true for cathode rays. Right. Now let's come back and read the next question, students. Here what do they give us? Ethylene glycol on oxidation with periodic acid gives. Okay, ethylene glycol on oxidation with periodic acid. Let's write the reaction first. Ethylene glycol is what? CH2OH, CH2OH. What is periodic acid? HiO4. This is periodic acid. Correct? So basically the reaction is simple. Let me just show you. Just see here. First important thing, HiO4 gets converted to HiO3 with evolution of water molecule. Now the leftover is HCHO. HCHO, 2 moles. Done. So what is the answer? The correct answer is formaldehyde. Right. So this is your option. Now let's see the next question of set 10. What did they give me? Which of the following compounds does not have a carboxylic functional group? Don't go with this number, students. Number is a bit wrong. So let us see the question. Which of the following compounds does not have a carboxylic functional group? Picric acid, ethanoic acid, aspirin, benzoic acid. They said which of the compound does not have carboxyl functional group? Not this one, carboxyl functional group. What is carboxyl functional group? Basically, carboxylic functional group is COOH. Let's write the structures. For the first one, picric acid structure is benzene ring, OH, NO2, para position NO2, ortho position NO2. This is picric acid. Next one, ethanoic acid. That's the CH3COH. There is a carboxylic group. Third one, aspirin. What is aspirin structure? That's nothing but acetyl salicylic acid, isn't it? Okay, aspirin structure. Okay, OH. This is aspirin structure, correct? Right, so COOH group is also here, carboxylic group. Fourth one, benzoic acid. What is benzoic acid structure? Ring. COOH is benzoic acid. Here also there is COOH, correct? Here also there is COOH, carboxylic group. Here also there is carboxylic group. Here also there is carboxylic group. So picric acid is only compound which doesn't have carboxylic function group. So picric acid. So remember this, students. So picric acid does not have carboxylic function group. Let us see the next question. I think same question I've done it already. Let me read this. Which of the following compound does not have any geometrical isomers? So why some questions are repeated? Because the most important questions are picked up again and again to teach you all, right? So here what did they give me? Which of the following compound does not have any geometrical isomerism? What did I say to remember? Whenever if a compound has to show geometrical isomerism, what is important? You should have atoms on different carbons. Means carbon atom should be on different, means like chloride, bromide, all these atoms should be present on different carbon atoms. Here also different, here also different, here also different, but here in this case they're present on the same carbon. It will not show, means even if you rotate it, it will not show any isomerism. So for geometrical isomerism, different atoms or similar atoms. Let us write similar also, no problem. Here all are similar, isn't it? Similar atoms should be present on different carbon atoms, correct? Yes. So here in this case it is present in the same, so this will not show geometrical isomerism. Simple, isn't it? So option D is the correct answer. Right. Now let's come back and do one more question. Now let's see the next question, one more organic based question. Let's read this. The IUPAC name of this compound is what? IUP is the name of this. So basically let us start numbering this compound. Done? Fine. So we very well know double bond is given preference. So 1, this is 2, this is 3, this is 4. Now see the compound. Bromo is present in second position. So 2 bromo. Correct? Chloro is present in the first position. 1. Bute. 1, 2, 3, 4, 4. Double bond is present in the first carbon. So bute 1A. So the correct option, the IUPAC name for this is 2 bromo, 1 chloro, bute 1E. Done? Yes. So next question. Let's come back and do the next question, students. So next question is again a solid state chapter question. Let's do this. Let us understand carefully. It's very easy basically. Let's read. A metal crystallizes in FCC, that is face centered cubic lattice or crystal lattice. So let us draw one FCC lattice, a face centered cubic crystal lattice. So in FCC you have all the atoms on the faces, isn't it? So this is one, this is one, this is one. Done? Yeah, this is the one face, this is one more, this is one more, this is one more, and towards me this is also one more, and one more is towards me. Done. If the edge length of the unit cell is A, the closest approach between two atoms in metallic crystal would be. Closest approach, this is the keyword which you have to see. So if I have to take this face, how does this face look like? Let me draw this. I have drawn one diagonal, 1, 2, 3. This is the ring. The edge length is A and A. Okay, this is R, this is R. Done? Fine. Now, according to, okay, let me take from here till here. Let me take this as X. Now, according to the Pythagoras theorem, A square plus A square is equal to X square. the square of the hypotenuse, right? This is the hypotenuse, so that I have taken as x square. A square and a square, this becomes 2a square is equal to x square. X is equal to root 2a. Done? Right. Now what did they say? Here, one more thing we have to solve. How many r's are here diagonal? Because we have to say take the closest approach, isn't it? How many r's are there? 1 r, 2, 3 and 4. Correct? So 4r is equal to root 2a. Correct? Yes. Now they further I can write r is equal to, I can calculate this further. I can calculate it as 1 by 2 root 2a. Correct? Yeah. Now they have given nearest or the closest approach. So here r is equal to 1 by 2 root 2a. I am taking 2 above because nearest approach means this and this. Closest one I have to take. So I am taking 2 above. 2r is equal to a by root 2. Done? A by root 2. So the correct answer for this is a by root 2. Option C is the correct answer. Right. Let us come back and do the next question. What we have, let's see this. Yes, next question. Which amongst the following compounds have the highest acid strength? Okay. So whenever a question of acid strength is given to you, again the question solved, very important question. Again I'm solving it, just understand. Whenever somebody asks you what is the highest acidic strength, you have to remember, whenever there is an electron withdrawing group, acidic strength increases. Whenever electron releasing groups are present, acidic strength decreases. Now among all these, which is electron withdrawing? This one pulls the electron density. Then after that, this comes oxygen. After that, this compound, and this is electron releasing, isn't it? If electron releasing there, acidic strength decreases. So they said highest acidic strength is the first compound, CF3COH. This will be greater than the next one, MbOCH2COH. After this will be greater than CH3COH. This will be greater than ethyl group, COH and C-methyl group. Because this is electron releasing group, this is electron withdrawing group. That's it. So correct option is CF3COH.